is the solution, supposedly, to homework number 3 in ES110. So we have a care package from an overly caring parent has arrived at the University of Hartford mailroom in a crate that weighs 1/2 tons. That's a caring parent. Is rigged by 2 ropes as shown, and the angles are 30 degrees and 25 degrees. Okay, I guess I'll buy that. Determine the magnitude of the tensions in each of the cable, FAC and FBC, and you must draw a free body diagram. So let's look here and get to work. Okay, let's zoom in here. And so this is page 1 right here, and I am Dr. Deal. And this is spring. I thought it was going to be fall. People yelling in the background. Spring 21 and ES110, and this is homework 3. And let's hope that we make less mistakes this time, because I'm tired of making mistakes. So let's see, I'm going to move this over to the side so I can read it. And get my nice ruler out here, and it's problem 1. And we will write out, here's the box. Right there is D, and this ring right up here, and something like that. And this is kind of hard to, it was hard to actually get this thing in a configuration where it wasn't where it wasn't hitting that corner right there. So we'll put a little ring right there. Okay, and so that right there is going to be theta A. That right there is theta B, and right here, and so the givens are going to be that the weight of D is equal to 1,000 pounds. Theta A is equal to 30 degrees, and theta B is equal to 25 degrees. And we want to find F, let's see, I decided to call this A, C, and B. So we want to find F, AC, and F, BC. So we start out with a free body diagram. And we draw straight down over to here, and over to here. So, and we're going to declare what X and Y are. Right here is going to be theta B. This is FBC. This is the weight. Oops, falling off the side here. And this is going to be FAC. And I guess I'll go ahead and put the angle right in there of theta A. So if we take the sum of the forces in the x direction, and that's positive right there, we say we have a negative FAC times the sine of theta A. I guess I've decided to leave it as variables, plus FBC times the cosine of theta B equal to 0. So we could solve for either one because we're going to find for both of them. So I think I'm just going to go FAC is going to be equal to, so it's going to be I'll go, let me put it this way right here. I'll go cosine of theta B sine of theta A, right, because we would be dividing over here, FBC, and Do I have enough room to write it over to there? I guess I will be lazy and say the cosine of 25 degrees divided by the sine of 30 degrees. Did I get that right? Yep. FBC is going to be equal to 1.813 FBC, and I'll write out the FAC. Okay. Now we need to move the keyboard over so we can slide this up. And keep working. Okay, so now we want to take the sum of the forces in the y direction. Positives right there. And okay, so we're going to have FAC times the cosine of theta A minus W and minus FBC times the sine of theta B equals 0. Now we can substitute the stuff that we know. So we could go 1.813 times FBC times the cosine of theta A, which is 30 degrees, minus 1,000 pounds, minus FBC times the sine of theta B, which is 25 degrees, equals 0. And we're going to be able to find FBC this way. So first off, okay, so I'm going to take 1,000 right here, enter, and that's going to jump over to this side over there. So we're going to take, flip them here, 1.183, multiply it by the cosine of 30 times there, okay. And then we're going to subtract out the sine of 25. We're left with this, and now we're going to divide 1,000 by it. And I wonder if I got it right. 871.7 pounds is what I think that's going to be. And then I can put it back up here into that equation 1 right there. And so FAC is going to be equal to 1.813 times 871.7. So 1.813, double checking, yep. So we get this 1,580 pounds. That's a pretty impressive amount right there. Okay. So even though the thing weighs 1,000 pounds, isn't that a little counterintuitive? I guess not, because we have to. This is a good reflection right here. This guy is going to be pulling downwards in order to keep this thing off from there. So it stands to reason that this is going to have some additional downward pull than just the 1,000. So that's the thought process there that we could go through. We might, if we still don't agree, we might want to keep looking for some mistakes. But let's write down the answers. We have FAC, 1,580 pounds in tension, and then FBC is 870. Could have had 872 if we want. 871 pounds also tension. And that doesn't look like there's an R right there. Okay. We're done. So that's problem 1. And wouldn't doubt that I made some mistakes. And seem to be making a lot of them lately.